We have started 7D exercise. The topic presently running is the areas under curves. So, this is the fourth problem from third Roman 7D exercise. Show that the area enclosed between the curves y square equals to 12 into x plus 3 and y square equals to 20 into 5 minus x is 64 into root 5 by 3 is what we have to prove. So if you see this, these two are the parabolas, but not the regular or standard form of the parabolas. The parabolas are said to be in its standard form if and only if the vertex is at the origin. So y square equals to 4ax is y minus 0 whole square equals to 4a into x minus 0. Therefore, the vertex there is 0, 0. In the same way, x square equals to 4ay also can be written as x minus 0 whole square equals to 4a into y minus 0. The vertex is origin 0, 0. Here, since here one more thing is that actually the limits are also not given. That means these two parabolas are intersecting each other at one point. That one point can be obtained through solving the two parabolas. That is point number 1. And so very first given parabolas are y square equals to 12 into x plus 3. This can be rewritten as y minus 0 whole square is equals to 12 into x minus of minus 3. Therefore, this is the parabola. This is the parabola having vertex at minus 3 comma 0, because it can be compared with y minus k whole square equals to 4a into x minus h. Therefore, it's a parabola h comma k is minus 3 comma 0. This is a parabola having vertex at minus 3 comma 0, and it is, see, y power even symmetric about x axis. X has a sign positive here. So it is symmetric about positive x axis. Positive x axis. So a rough diagram for which is, so 1, 2, 3. So this is x minus of minus 3. Okay, and 4, 5, minus 1, minus 2, minus 2, minus 3. So based on the vertex minus 3 comma 0. Okay, and it is symmetric about x axis. So x axis is acting like a mirror, and in the positive x axis, it is opening in positive x axis. Therefore, the rough diagram for which is this. So this parabola is this y square equals to 12 into x plus 3, and another parabola is y square is equals to 20 into 5 minus x. This can be written as y square is equals to minus 20 into x minus 5. So minus I have taken common, then x minus 5. This can further be written as y minus 0 whole square equals to minus 20 into x minus 5. So therefore, this is a parabola having vertex at 5 comma 0. This can be compared with y minus k whole square equals to minus 4a into x minus h. vertex at 5 comma 0 and is symmetric. Here y power will symmetric about x-axis. Which x-axis? Negative x-axis. Symmetric about negative x-axis. So that means this is 1, 2, 3, 4, 5. So this is 5 comma 0. Then this is this parabola. So that means both are intersecting. But intersecting at which point? That is the thing. So this is 5 comma 0. So having the vertex at 5 comma 0, it will be a parabola whose vertex is at 5 comma 0 and which is symmetric about x-axis again like this. But here opened in negative x-axis. So this is the negative x-axis opening. And so somewhere at one point both these parabolas will be intersecting each other. That point of intersection will be obtained through solving these two. So solving the given parabolas, we get, since both are y square equals to y square equals to, therefore it can be equated. 12 into x plus 3 equals to 20 into 5 minus x. So 4 3 is 12, 4 5s. So this is equals to 3x, 3 3s are 9. So next 5 5s are 25 minus 5x. This is equals to 3x plus 5x, 8x is equals to 25 minus 9, 16. Therefore x is equals to 2. Therefore having vertex at 5 comma 0, this is minus 3 comma 0. Having vertex at 5 comma 0, these two are intersecting at x equals to 2. So actually both are intersecting at this x equals to minus 2. Okay. So this is the data given. And here if you see the area of the region is A is equals to minus 3 to 2, minus 3 to 2, this curve. So minus 3 to 2, so which curve, these are the limits of x. Therefore dx means y dx plus 2 to 5 are the limits of x. So dx means y dx. Now minus 3 to 2, here which curve is this? This curve is y square is equals to 12 into x plus 3. This curve. And this curve is y square equals to 20 into 5 minus x. So here what this parabola is y square equals to 12 into x plus 3. Therefore if you want y, it is square root of 12 into x plus 3 dx plus 2 to 5. This parabola is 20 into 5 minus x, y square. If we want y, then it is square root of 20 into 5 minus x dx. If you do so, then actually the above curve only we are going to get. So for getting the total curve, this is the area of the region symmetric about x-axis. Therefore this part only we are going to get. If you want this also, the answer we have to multiply with the 2 is equals to root 12 is 4 3s are 12. So 2 root 3 separated from the process of integration. Integral root x is 2 by 3 x power 3 by 2. So therefore the process of integration is over here. So from minus 3 to 2 plus root 20 is 4 5s are 20. So 2 root 5 into root 5 minus x. Let root 5 minus x be x. So root x derivative is root x integration is 2 by 3 x power. So 5 minus x whole power 3 by 2 pi. Quotient of d by dx of 5 minus x is minus 1. Here d by dx of x is plus 1, therefore no need to divide, but here we need to divide into, so here instead of here I will write here. So since the process of integration is over, 2 to 5 is to be written here. Now this root 3 cancelled in this root 3 times. So 2 2s are 4 by root 3. Now apply the upper limit. So x value is 2. 2 plus 3, 5 power 3 by 2 minus lower limit. X is minus 3 plus 3. So it will be 0. 4 power 3 by 2 is 0. This is plus into minus. So minus 2 2s are 4 root 5 by 3 into here 5 minus upper limit is x. X is 5 power 3 by 2 minus lower limit 5 minus x value is 2 whole power 3 by 2. This is equals to 4 by root 3. 5 power 3 by 2 is 5 root 5 minus 4 root 5 by 3 into this value is 0. 5 minus 2 is minus 3, minus of minus plus 3 power 3 by 2 is 3 root 3. This is equals to, so here 5, so minus of minus is plus 4 root 5 by 3, this is minus. So 5 minus 2 is 3 power 3 by 2, so minus 3 power 3 by 2, minus of minus is plus. This is equals to 4 5s are 20 root 5 by root 3 plus 3 gets cancelled, so 4 into root 5 into root 3. This is equals to root 3 is the LCM here, so 20 root 5 plus root 3 into root 3 3 4s are 12 into root 5 12 root 5. This is equals to 32 root 5 by 3. So root of 5 by 3. Here this area is only we are getting. So this is the, if I multiply with a 2, then actually this area also we are going to get. So therefore total area is equals to 2 into 32 root 5 by 3, that is equals to 232 64 root of 5 by 3 square units. The circle x square plus y square equals to 8 is divided into two parts by the parabola. That means circle is there and parabola is there. First let us try to draw the diagram. So this is the coordinate axis and this is the circle. This is the circle. Now this is x square plus y square equals to 8. That means x square plus y square equals to root 8 whole square. X square plus y square equals to r square. R value is root 8. That means 2 root 2. So this is 1. This is 2. This is 2 root 2. So this is 1. This is 2. This is 1. This is 2. This is 2 root 2. So this is 0 comma 2 root 2. This is 2 root 2 comma 0. This is 1. This is 2. And this is 2 root 2. 2 root 2 is 2 into root 2 is 1.414. So that is below 3. So this is equals to, that means 2.828, which is nearest to 3. Okay. So this is minus 2 root 2 comma 0. This is also, this is 1 and this is 1, this is 2 and this is 0 comma minus 2 root 2. Okay. And now 2y is equals to x square. So x square equals to 2y is the standard form of the parabola because this can be written as x minus 0 whole square equals to 2 into y minus 0. So therefore 0, 0 is the vertex. X power even symmetric about y axis. Symmetric about y axis. Which y axis? Positive y axis. So it will be like this. So like this parabola. And if I am trying to draw this parabola, then actually circle and parabola are going to intersect each other at one point, at 2 points, here and here. So that point of intersection we will be getting through solving these two. So that is why solution given circle is x square plus y square is equals to 8, whose center, this is the standard form of the circle whose center is at the origin, whose center is at the origin and having radius is equals to root 8, that is 2 root 2, and given parabola is x square is equals to 2y, which is a standard form of the parabola. This circle is also standard circle. Given circle is a standard circle. Standard circle. The circle is said to be in its standard form if and only if its center is at the origin. The parabola is said to be in its standard form if and only if the vertex is at the origin, which is a standard form, which is in standard form whose vertex is at the origin, and so x power even symmetric about y axis, and it is symmetric about which axis? Positive y axis. Symmetric about positive y axis. So that's what I have shown in the diagram. This is symmetric about positive y axis, and the point of intersection, of circle comma parabola is, so here y is equals to x square by 2. So from this y is equals to x square by 2. So solving them we get, so x square plus y is equals to x square by 2, y square is x square by 2 whole square, x square by 2 whole square is equals to 8. This is equals to x square plus x power 4 by 2 square 4 is equals to 8. This is LCM, 4x square plus x power 4 by 4 is equals to 8. So 4x square plus x power 4 is equals to 4 8s are 32. This implies x square whole square plus 4x square minus 32 equals to 0. Let x square is equals to t will take. This is t square plus 4t minus 32 equals to 0. This is a quadratic equation in terms of t. Therefore, it must have two roots. So here 132, 32. 8 4s are 32. 8 minus 4 is 4. So t square plus 8t minus 4t minus 32 equals to 0. That implies t into t plus 8 minus 4 if I take common, then this is t plus 8 equals to 0. That implies t plus 8 if you take common, then this is t minus 4 equals to 0. T plus 8 equals to 0. T is equals to minus 8. But t is not equals to minus 8 since t value is x square. X square is equals to minus 8. X is imaginary because x square is equals to minus 8. X equals to root minus 8, which is imaginary. So this is not going to be the one. And t minus 4 equals to 0. That means t is equals to 4. That means x square equals to 4. Therefore, x is equals to plus or minus 2. That means, see, didn't I tell you? This is t minus 4. So t x square equals to 4. X equals to plus or minus 2. Therefore, this one. So this is a parabola. This is a parabola which is symmetric about y-axis and open in positive y-axis, and which cuts this circle at this 2 and minus 2. This is 2 and minus 2. Therefore, actually here two areas arise. Here, find the area of both the parts. That means this area and the remaining area. This area we need to find out. Therefore, area is equals to from minus 2 to plus 2. From minus 2 to plus 2. Here, this is the circle and below that is the parabola. So, this is the, with respect to x-axis, the above curve is the circle minus, below one is parabola, c minus p dx. So, minus 2 to 2, we want minus 2 to 2 are the limits of x, therefore dx means y dx. So, minus are there. This is circle, x square plus y square equals to 8. So, y square is equal, y I want. Y square equals to 8 minus x square. Therefore, y is equals to square root of 8 minus x square. This circle. And below which the parabola is there. What is the parabola? X square is equals to, this is x square equals to 2y. From this, y is equals to x square by 2 minus x square by y dx, no? So, x square by 2 whole dx. This is equals to, we have a property that we have minus a to a f of x dx is equals to 2 integral 0 to a f of x dx if f of minus a is equals to plus f of minus x equals to plus f of x. So that is why let f of x is equals to square root of 8 minus x square minus x square by 2. So then f of minus x is also square root of 8 minus x whole square minus x whole square by 2. So it is going to be the same f of x. Therefore, this can be written as 2 integral 0 to 2 8 minus x square minus x square by 2 whole dx. This is equals to 2. This is we have a formula, root a square minus x square dx, integral x by 2 root of a square minus x square plus a square by 2 sine inverse x by a. This formula we have. So, based on that, x by 2 root of 8 minus x square plus a square by 2, 8 by 2 sine inverse x by a. X by a is root 8. A is, this is a square. So, root 8 whole square. This is root 8 whole square. Therefore, a is root 8. So, a square by 2 sine inverse x by a. X by a is root 8 minus integral 1 by 2 integral x square dx is x cube by 3. Therefore, the total process of integration is over. Now, apply the limit 0 to 2 here. So, now, this is 2 into, now substitute the upper limit. So, 2 by 2 square root of 8 minus 2 square 4 plus 4 sine inverse x is 2 by 2 root 2 minus 1 by 6 x cube is 2 cube. This is whole upper limit. This is whole upper limit minus lower limit. So 0 by 2 is 0. This is all 0. 4 sine inverse 0 by 2 root 2. Sine inverse 0 is 0. So 1 by 6 x cube is 0. So this is all 0. This is equals to 2. 2 gets cancelled. Root 4. 8 minus 4 is root 4. Root 4 is 2. Plus 2 gets cancelled. 4. Sine inverse 1 by root 2. Sine inverse 1 by root 2 is pi by 4. Because sine pi by 4 is 1 by root 2. Sine inverse 1 by root 2 is pi by 4. Minus 2 cube 8 by 6. So this is 4. This is 3 times. 4 gets cancelled. 2 into, this is 2 minus 4 by 3. 3 2s are 6 minus 4, 2 by 3. This is 2 by 3 plus pi. So this is 2 2s are 4 by 3 plus 2 pi. This is the area of this circle. Now to obtain the remaining part. So this is totally, this only we get. So this is total circle I want. So that means, so this is what I got, right? To get this is area of one part. So the area of remaining part is equals to area of circle minus area of first part. So this is all circle. Circle's area minus the area that we get right now. If you subtract, then actually the remaining area, this we will be getting. This we will be getting, right? This is equals to area of a circle is x square plus y square equals to 8 is the circle. Therefore, area is pi r square. So 8 pi. This is r square, no? X square plus y square equals to r square. So area of the circle is pi r square. R square here is 8. So therefore this is 8 pi minus of 4 by 3 plus 2 pi. This is equals to 8 pi minus 2 pi is 6 pi minus 4 by 3 square units. Show that the area of the region bounded by x square by a square plus y square by b square equals to 1, which is ellipse, is pi ab. Also deduce the area of the circle. So, let us take this the coordinate axis. Now, So this is O or C. C, A, A dash, B, B dash. This is x square by a square plus y square by b square equals to 1. So this is a comma 0 minus a comma 0. This is 0 comma b and this is 0 comma minus b. So this is a dash is the major axis. The length of the major axis is 2a and the length of the minor axis is 2b. So here a is greater than b. A is greater than b. To be more specific, a not equals to b. So therefore this is the ellipse is said to be in its standard form if and only if its center is at the origin. So now given equation of the ellipse is x square by a square plus y square by b square equals to 1, from which y square by b square is equals to 1 minus x square by a square. This is equals to y square is equals to a square minus x square by a square into 1 by b square. If you transpose to that side, it is equals to into b square. Therefore, y is equals to plus or minus b by a into square root of a square minus x square. So y square, square root of y square, square root of b by a whole square, square and root gets cancelled and this have what? Root a square minus x square. Now, area of the region bounded by ellipse in first quadrant Q1. So this is area is equals to from 0 to this is 0 0 0 to a is the on the limits of x. Therefore dx we are going to get, if this is dx, y dx. Y is anyway the function of x itself. That's why before this step actually we have prepared x square by a square plus y square by b square equals to 1 in terms of y. So this is equals to 0 to a. What is y? B by a. So b by a into root of a square minus x square. Since b by a is constant and I have separated from the process of integration. So b by a, this integration we know. Integral root a square minus x square is x by 2 root of a square minus x square plus a square by 2 sine inverse x by a. This is from 0 to a. This is equals to b by a. Now substitute the upper limit. A by 2 into root of a square minus a square plus a square by 2 sine inverse x by a is a by a minus the whole in this I have substituted the upper limit a. Now the lower limit is 0 by 2 into something 0. A square by 2 sine inverse 0 by a is 0. So this is all 0. This is equals to b by a this is equals to b by a into this is a square minus a square is 0. This is all 0. A square by 2. This is sine inverse 1. Sine inverse 1 is pi by 2 because sine 90 is 1. Sine inverse 1 is pi by 2. So a gets cancelled. This is pi ab by 4. But this is the area of the region bounded by the ellipse in the first quadrant itself. Such quadrants are 4 totally. Therefore, total area is equals to 4 into pi ab by 4. This is 4 gets cancelled. Phi AB is the area, and not only this, also deduce the area of the circle. So the ellipse to be the circle, the ellipse to be the circle, this is the ellipse to be the circle. Here this is A and this is B. A is greater than B, otherwise in essence A not equals to B. For this ellipse to be a circle, this and this should be equal. That means this is A and this B is also A. B is also A. So that means for this ellipse to be a circle, A is equals to B. Therefore, area of circle is equals to pi A. B is also A. So pi A square. Let OAB be the positive quadrant of the ellipse. With OA is equals to A, OB equals to B, then show that the area bounded between the chord AB and the arc AB of the ellipse is pi minus 2 into AB by 4. So, let us suppose that this is the ellipse. So this is the ellipse. So this is equals to O, A, B. Given that OA is equals to A, this is A, and this is OB equals to B. This is x-axis, negative x-axis, y-axis, negative y-axis. OB equals to, then show that the area bounded between the chord AB. So, what is the chord? The line joining the points AB is said to be the chord. So, this is the chord. Now, here, between the chord AB and the arc AB is this. So actually he is asking us to find the area of the region bounded by this chord and the arc. So can you tell me what is this line? This line is x by a plus y by b equals to 1. Since, so in first year we have learned that this is AB. This line cuts the coordinate axis at a comma 0, B 0 comma B. This is x-intercept and this is B is y-intercept. Then this is x by A plus y by B equals to 1. Therefore, this is the equation of the line in the intercept form. So therefore, given ellipse is x square by a square plus y square by b square is equals to 1. So here, the area of the region bounded by this chord I want, this arc and this chord. So, between this is 0 comma 0, this is a comma 0. That means from 0 to a dx, y dx. So, y we want. So, last problem we have discussed y is equals to b by a plus or minus square root of a square minus x square. Now, this is therefore the equation of the arc AB is this, and the equation of the chord AB is x by a plus y by b equals to 1. From this, y by b equals to 1 minus x by a. So y is equals to a minus x by a minus x into this is b by a. Okay. Now therefore the area of the region bounded by the chord, the arc and the line. So 0 to a arc minus chord, because here the arc is the dominating curve and this is the lower curve, the chord dx. So this is y dx only. 0 to a, what is the chord arc? b by a into square root of a square minus x square minus, what is the chord? Chord is a minus x into b by a whole dx. This is equals to b by a is common in both of them. This is 0 to a square root of a square minus x square minus of a minus x dx. So this is equals to b by a into integral root a square minus x square dx is x by 2 root of a square minus x square plus a square by 2 sine inverse x by a minus integral a dx is ax minus into minus plus integral x dx is x square by 2. Since the process is over, so 0 to a is to be written here. This is equals to b by a. Substitute the upper limit. So a by 2 root of a square minus a square. So this is 0. A square by 2 sine inverse a by a, which is 1. Sine inverse a by a. Sine inverse 1 is, this is sine inverse. In the place of x, substitute a. A by a is sine inverse 1, which is pi by 2. Minus a, in the place of x, a into a square plus a square by 2. So this is all upper limit minus lower limit. In the place of x, substitute 0. 0 by 2 into something. This is 0. A square by 2 sine inverse 0 by a. 0 by a is 0. A into 0, 0. A square by 0 square by 2 is 0. So the whole is 0. Now this is b by a pi a square by 2 to the 4 minus, here a square by 2 minus 2a square is here minus a square plus a square by 2. LCM is minus 2a square plus a square by 2. So minus a square by 2. Minus 2a square plus a square is minus a square by 2. So that implies b by a into, take 4 as an LCM. This is pi a square minus, this is 2a square. That implies b by a, this is, take a square in common, then this is pi minus 2 by 4. This is equals to a gets cancelled. This is what we need to get. So pi minus 2 ab by 4. So prove that the curves y square equals to 4x, x square equals to 4y, divide the area of the square bounded by the lines x equals to 0, x equals to 4, y equals to 4, y equals to 0 into 3 equal parts. That means y square equals to 4x is the parabola, which is the standard form of the parabola whose vertex is at the origin. It is also standard form of the parabola whose vertex is at the origin and x power even symmetric about y axis, that is positive axis. This is upward parabola, this is right parabola. So square bounded by x equals to 0 is y axis, X equals to 4 is the line which is vertical, which is parallel to y axis, which is a vertical line. Y equals to 4, which is a parallel to x axis, a horizontal line, and y equals to 0, x axis into 3 equal parts. So first of all, x equals to 4. For example, this is the 1, 2, 3, 4, and otherwise if you take 2 units, 2, 4, this is 2, 4, this is given. So this is how much? So this is 4 and this is also 4. 4 the area of square is equals to 4 into 4, 16. Now here 3 equal parts. That means, so actually, for example, we are going to have a parabola, these two parabolas like this. Therefore, this is 1, this is 2, this is 3. So these 3, that is one parabola, down parabola. Therefore, this is one area, this is one area, this is one area. So 3 parts into equal parts means 16 by 3, 16 by 3, 16 by 3. So actually, this is how we need to get. So given parabolas are y square equals to 4x, whose vertex is at the origin, and symmetric about y power even symmetric about x axis, positive x axis, and is symmetric about x axis, positive x axis, and x square equals to 4y, vertex again at origin and symmetric about x power equals symmetric about y axis, positive y axis, about positive y axis. So let us try to draw the diagram now. That is the rough diagram. So now this is y square equals to 4x, y power even symmetric about x axis, positive x axis. Therefore, this is the y square equals to 4x. This is y square equals to 4x. Now, x square equals to 4y, x power even symmetric about y axis, positive y axis, right? So this is this. This is x square equals to 4, x square equals to 4y. And now, this is 2, this is 4, and this is 2, this is 4. Therefore, this is a what? This is y axis, this is x axis, y equals to 0, this. And this is y axis, x equals to 0. So, this is the line which is parallel to x axis. Any line which is parallel, this line is parallel to y axis. Any line which is parallel to y axis is the form, this is x equals to 4. And this line is parallel to x axis. Any line which is parallel to x axis is y equals to 4. Therefore, this is what I told you before. Now, here there are totally 1, 2, 3 parts. It is divided into 3 parts. So since this is the area of the square, so this is 4 and this is 4. So 4 4 is 16. So since it is divided into 3 equal parts, each should be 16 by 3, 16 by 3, 16 by 3. Let us take this to be 1 and this to be 2. and this to be 3. So what is our task? To show each one to be 16 by 3. So for this, let us do this. So area is equals to, so here 0, this is 4 comma 0. This is 0 comma 0. So 0 to 4 are the limits of x dx. Dx means y dx. So 0 to 4 here. This. So with respect to x-axis, this is upper curve. So what is this curve? This is y square equals to 4x. And this is this parabola is x square equals to 4y. Now y dx I want. So upper curve is y square equals to 4x. This is the upper curve. This is upper and this is lower. So y is equals to square root of 4x, 2 root x minus lower curve. I want this in y. So x square equals to 4y, y equals to x square by 4 dx. This is equals to 2, integral root x is 2 by 3, x power 3 by 2 minus 1 by 4, integral x square dx is x cube by 3. So therefore the process of integration is over. So here 0 to 4 is to be applied here. 2 2s are 4 by 3. In the place of x, upper limit 4 power 3 by 2 minus 1 by 4 3s are 12. X cube is 4 cube minus, this is all the upper limit, minus lower limit is 2 2s are 4 by 3, x is 0 power 3 by 2, this is 0. Here 1 by 4, 0 cube by 3, this is all 0. Therefore this will be 4 by 3. 4 is 2 square whole power 3 by 2 minus 4 cube is 64 by 12. Square root gets cancelled. 2 cube 8, 8 4s are 32 by 3 minus 64. 4 3s 4 16s. 16 by 3. So 32 minus 16 by 3, which is 16 by 3. So this is equals to 16 by 3 we get that. Now, so second part. This is first part. Now second part is, what is the second part here? So area is equals to, from 0 to here 0 0, this is 0 comma 4. So 0 to 4 are the y limits now. So therefore dy should be taken into consideration, x dy. 0 to 4 here. Now this area, see this area I should get now. Okay, this is the part of y square equals to 4x curve. This is y square equals to 4x and this is y axis. Y axis in the sense x equals to 0. So from this y square equals to 4x. See, as far as x axis is concerned, upper curve minus lower curve. As far as y axis is concerned, a rightmost curve minus leftmost curve. This is right and this is left. So this is y square equals to 4x. So from this are the limits of y dy. Dy means x dy. So 0 to 4 here y square equals to 4x, x equals to y square by 4 minus, this is y axis. Y axis is x equals to 0 dy. This is equals to 1 by 4 you separate from the process of integration. This is y cube by 3. The process is over 0 to 4. Now 4 3s are 12. 1 by 12 into y is 4 cube. So 64 by 12 is 64 by 12 is 16 by 3. This is the second part. And now the third part is this. The third part is this is the curve and so this is the curve and this is the line. So this is the line and this is the curve. So from 0 to 4, this is 0, 0, this is 4, comma 0. So area is equals to 0 to 4. So with respect to x-axis, the upper curve is this. This is the part of x square equals to 4y. This is x square equals to 4y. I want what? Since this is the x limits, x y dx I want. From this x square by 4. Again, 0 to 4 are the limits of x. So dx I want. Dx, then y dx. So x square equals to 4y, y equals to x square by 4 minus. This is the upper curve. And this is the lower curve. What is this? X-axis. X-axis equation is y equals to 0. So minus dx. So here also we will get the same 1 by 4 into x cube by 3. The process is over. 0 to 4. 4 3s are 12. X cube is 4 cube 64. So this is also 16 by 3. So if you see, this is 16 by 3. This is 16 by 3 and this is 16 by 3. Therefore, the total square divides. So, the square divides this into 3 equal parts.